Operations on vectors. If we have two vectors A and B, then we can define the addition A plus B using two equivalent methods. We can take the vector A, then take the end of the vector A and sketch the vector B. And after that, take the beginning of the first vector, here vector A, the first vector, and the vector B, second vector. Take the beginning of the first vector, ending of the second vector. So this is the vector A plus B. If we consider B as the first vector and A as the second vector, so we can take the beginning of the vector B, here the vector B in blue, and the ending of vector A in black. So this is the vector A plus B. This is method one. Also, we can define A plus B using the method of parallelogram. Let's take A and B. Now, in this case, I will take the beginning of the vector A and the vector B is the same. Then after sketching A and B, we will continue, we will make a parallelogram constructed on the vectors A and B. Then I will take this point, then this is the vector A plus B. Now, after the addition of two vectors, let's take the product of a vector. Second operation on vectors is the product of a vector by a number. So for any number lambda, real number, we can define the number lambda times the vector A. Let's begin by giving some examples. If the vector A is given like this, so this is the vector 2A in the same direction, parallel to A, and the length of this vector is 2 times the length of A. And here you have the vector 3A, here you have the vector half A, or you can write it A divided by 2. So here this vector parallel to A, and the length of this vector half of the length of A. Here you have the vector minus A, here minus 2A, etc. So in general, the vector lambda A is always parallel to the vector A, and the length of this vector will be the absolute value of lambda times length A. So the definition of lambda times A is like this, given by these two remarks, 3 and 4. If lambda positive, for example, 2, so this vector lambda times A is 2 times as the length of the vector A and parallel to A. So it will be in the same direction of the vector A and parallel to A, and I know the length of this vector. If lambda less than 0, for example, minus 2, so the vector lambda times A is minus 2A, parallel to the vector A, but in the inverse direction, in the opposite direction of the vector A. Now, after that, how to define the operation minus subtraction of two vectors? A minus B is defined as A plus the vector minus 1 times B. So property number 2 here, that if two vectors are parallel, then one of these two vectors could be written as lambda times the second vector, where lambda is f If they are, let's suppose that the B and A in the same direction, then lambda will be length B over length A. If B and A in different direction, but they are parallel, then lambda will be minus length B over length A. Finally here, we can generalize the last definition of the addition of two vectors. In this case here, for more than two vectors, for three vectors. So if we have three vectors A, B, C, then the vector A plus B plus C will be like this. The beginning of the first vector and the ending of the last vector. Now in this question, sketch the vector 3i plus 2j. So I know that I is the unit vector of the x-axis. It's a vector. The vector I is parallel to the x-axis and in the same direction and of length 1. The vector j in the same direction of y-axis and of length 1. So what is 3i? So the vector 3i is given here in yellow. Okay, so I is given in blue, so it's 3 times the vector I. The vector 2j is given here in pink. So to sketch the vector 3i plus 2j, it will be like this. This is the vector 3i plus 2j. Next exercise, sketch the vector 2i plus 3j plus 4k. So we have in blue here 2i, blue, 3j is given in green here, and 4k is given in pink here. So the sketching will give me, because they are consecutive vectors, so using the rule, this is my vector A, 2i plus 3j plus 4k. Okay, in this exercise, let A 6i minus 8j plus 10k, vector B I minus j, vector C minus 9i plus 12j minus 15k. So question number 1, find A minus 2b. So A minus 2b, I will take 6 minus 2 times 1, because here I have 1. So 6 minus 2, it's 4. So let's write at first A minus 2b. This is question number 1. I will calculate A minus 2b. So it's 6 minus 2, it's 4i. And minus 8, minus, so plus 2j, so minus 6j plus 10k. Question number 2. Is A parallel to C? So let's take, let's divide 6 over minus 9. Is it equal to minus 8 over 12 and equal to 10 over minus 15? If this is correct, they are parallel. Let's verify. Let's cancel this. After cancellation, it will be, after dividing by 3, it's 2 over minus 3. Here, after dividing by 4, it's minus 2 over 3. And here, after dividing by 5, it's 2 over minus 3. So they are equal. So these two vectors, A and C are parallel. Also, we can solve using another method by writing the vector C equal, take this number -9 and this number 6. Can we write -9 equal number times 6, product by 6? It's minus 3 divided by 2. So it's minus 3 divided by 2a. It's not only for -9 and 6, and but also 12 equal -3/2 times -8. Also -15 equal -3/2 times 10. Okay, question number 3. The question number 3 is A parallel to B. If we take 6/1 here, is it equal to -8/-1? No, it's not correct. So they are not parallel. A is not parallel to B. Question number 4. In the question number 4, what is the length of the vector A? The length of the vector A will be root of 6/2 plus -8/2 plus 10/2. So it will be root of 200. Okay, why this formula is correct? Last one. We will see this after this rule in the following rule here. Next one. Okay, this rule. Okay, but let's see now this rule here. If I have a point A with coordinates x, a, y, a, and a point B, coordinate x, b, y, b. So the vector OA will be xa times I plus ya times j. Why? Let's take this vector xa times I is the blue one. And the other vector here, it's the green one, ya times j. So if I take the addition, will be the vector OA. Okay, now property number 2. If I take OB equals OA plus AB, then after that, I can write AB as OB minus OA. So if I use the last formula, that what is OB? OB, it's X, B, I plus Y, B, J. What is OA? Oh, it's XA, I plus YA, J. So let's take the subtraction. It will be XB minus XA times I. So I have this formula. Plus YB minus YA times J. So now this vector AB, I will sketch it in red. From A to B. The formula, we can understand the formula like this. This vector AB could be written as the x of the ending is the point B, minus x of the beginning, times the vector I. So this vector here, let's sketch it in blue. This vector here is the vector xb minus xa times I, plus, and also I can sketch this vector from this point from here to here. And the other vector in green, this vector, or this one, this vector is yb minus ya times j. Okay, this number yb times ya is negative. For this reason, this vector is in the inverse of the inverse direction of the y-axis. Okay, and you remark that the addition of these two vectors, green plus blue, will be the red one. Let's continue. So we have a rule here that if I have 2 points A and B, then the length of the vector AB will be root of xb minus xa, this length in blue, squared, plus yb minus ya, this length in green, squared, root. Okay. Now, this is also correct for 3 dimensions. So if I suppose the point M, ABC, as in the picture here, so let's calculate the vector OM. The vector OM, the length of the vector OM will be root of A squared plus B squared plus C squared Y. This is correct. Let's prove that. If we suppose the length L, let's sketch the length L here from this point to this point. Let's call this length L. So L, this is right triangle. So L equal root A squared plus B squared. Also, I have a right triangle from O to M, from the origin O to M. I have here right triangle. So also I can write now O, this is the origin OM. Here O and here M. So OM length equals root L power 2 plus C power 2. What is L power 2? It's A power 2 plus B power 2. This is L power 2 plus C power 2. And this proves that this proves my rule. Exercise. Let's A 1 5 minus 3, B 2 3 minus 5. Find the vectors AB and the length of the vector AB. So what is the vector AB? The formula was xb minus xa, subtraction, 2 minus 1, it's 1i, 3 minus 5 minus 2j, plus minus 5 minus minus 3, so minus 2k. This is vector AB. Now, length AB, using the formula, root 1 power 2 plus minus 2 power 2 plus minus 2 power 2. So it's root 9, so it's a 3. Next exercise, and here the question, find the addition of the vectors DA plus CB plus AC plus BD. If I take DA plus AC, what is the addition of these two vectors? It's DC. If I take now these two vectors, what is the addition of these two vectors? CB plus BD. The addition is CD. So finally, what is the addition of these two vectors? DC plus CD, it's DD. Vector DD means vector 0. So the final answer is vector 0.